Hi everybody, in this video I want to just go over one of the homework problems that has been giving a few people some problems. And I'm not doing the exact problem from the first homework set, but I'm going to give a similar one. And the problem is asking you to find the first 5 terms of a sequence, and it looks something like this, something involving n. And we often use n in math to mean a number. I know x also means a number, but n often we're dealing with numbers in sequence. And so what this means is we need to plug in values for n. And so we're going to do, starting with 1, n equals 1, and then we'll do n equals 2, and then we'll do n equals 3, n equals 4, and n equals 5. One common mistake is sometimes to start with n equals 0 rather than n equals 1. But 0 wouldn't be the first term of the sequence, it would be the 0th term of the sequence. And so, for example, for n equals 1, I would often put that there so I remember what I'm doing. And I just replace n with 1. So 6 times 1 is 6. 6 plus 8 is 14. For n equals 2, 6 times, that would then be 6 times 2 plus 8. 6 times 2 is 12. 12 plus 8 is 20. When n equals 3, we would then have 6 times 3, again, plus 8. So 6 times 3 is 18. 18 plus 8 is 26. For n equals 4, we would have 6 times 4 plus 8. 6 times 4 is 24. 24 plus 8 is 32. And you can probably already guess, without doing this multiplication, what the next number would be, because this is an arithmetic sequence. In an arithmetic sequence, we're adding the same amount to each term. And that could be a negative number. So an arithmetic sequence could get larger numbers or could get smaller numbers. But here, what number are we adding each time? Well, we're adding 6 each time. So even without doing the problem anymore, I know that my next answer is going to be 32 plus 6, which is 38. But again, just to make sure, I have 6 times 5 plus 8. And 6 times 5 is 30. 30 plus 8 is 38. And so then what I've asked you to do in Canvas for your answer is to type it in separated by commas and without any spaces. If you put in spaces, Canvas will count it wrong because Canvas is programmed to look for exactly what you type in. But I will mark it right when I go back and check the homework after the due date passes. So there's our answer. Let's do one more. If you want to stop listening, if you know it now, you certainly can. But let's try one that's a little bit trickier. Let's try n cubed. Let's do one that's subtraction. Let's do minus 5. And again, I'm looking for the first 5 terms in the sequence. So I'm going to look for n equals 1, and then n equals 2, and so on. We use the ellipses in math to mean and so on, all the way to n equals 5. So we'll start with n equals 1. That would be 1 cubed minus 5. 1 cubed is 1 times 1 times 1, that is 1. 1 minus 5 is going to be negative 4. And then next we'll have 2 cubed. Again, minus 5. 2 cubed is 2 times 2 times 2. That's 8. So we have 8 minus 5, and that gives us 3. Next we have 3 cubed minus 5. 3 cubed is 3 times 3 times 3, that's 27. So we'll have 27 minus 5, and that gives us 22. And then next we'll have 4 cubed minus 5. 4 cubed is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. 64 minus 5, that will give us 59. And then finally, when n equals 5, let's move this up a little bit. When n equals 5, we'll then have 5 cubed minus 5. So 5 cubed is 5 times 5, that's 25. 25 times 5 is 125. Minus 5 equals 120. And then what I've asked for you to do here, again, is to, in Canvas, you're going to just type in those values, separated just with a comma between each one, no spaces. So Canvas recognizes it. And again, these are just two examples. They aren't any of the exact homework problems, but it will hopefully help you with that. Now, this particular problem is not an arithmetic sequence, because to get from -4 to 3, well, I could add 7, but then to get from 3 to 22, there I'm adding 19. And to get from 22 to 59, there I'm adding 37. So clearly this is not an arithmetic sequence. I couldn't just guess at the next number like I could for the other one. And the reason it's not an arithmetic sequence is because we're cubing values first. So remember, with sequences, what you want to look for is to see when you're looking at numbers. So if I have 10, 16, 22, 28, and I want to see what type of sequences this is, I have to think, what are they doing to get from one number to the next? It has to be the same operation each time. And if that same operation is addition or subtraction, I have an arithmetic sequence. And technically it's not subtraction, it's adding the negative, it's adding the additive inverse. But in practical purposes, addition or subtraction. If it's multiplication or division, then I have a geometric sequence. If it's neither of those two, I still have a sequence, as we saw in the previous example, but it's not arithmetic or geometric. So here, to get from 10 to 16, what can I do? So some people might say, well, you can multiply, and I can. You can multiply 10 times a fraction to get to 16. So let's do that. So 10 times, well, it's actually 1.6. We'll write it as a decimal here. That would be the same as doing either 10 times 16 over 10 or 10 times 8 over 5. In each of these cases, we would get 16, same answer. So all these equal 16. So my next question is, can we do that same thing to 16? Can I take 16 and multiply it by 8 over 5? And will I get to 22 then? And I'm not going to get to 22. 16 times 8, I'm going to use a calculator here because I don't know 16 times 8 off the top of my head. 16 times 8 is 128. So that's 128 divided by 5, and 5 doesn't divide 128 evenly. And so my answer is actually going to be 25.6. And so although I can multiply by 1.6 to get from 10 to 16, that doesn't work here. And that means that this is not a geometric sequence. And so what this is an arithmetic sequence. What am I doing each time? I'm adding 6, because 10 plus 6 is 16, 16 plus 6 is 22, 22 plus 6 is 28. Sometimes people get mixed up a little bit with arithmetic sequences because they can look like geometric sequences if you only look at part of them. For example, if we had the sequence 0, 3, 6, 9, you might look at just these two middle numbers and say, oh, I know to get from 3 to 6, we're doubling it each time. So this must be geometric. We're multiplying by 2. But you have to check all the numbers. Can you multiply 0 by 2 to get to 3? No. And in fact, if you see 0 in a sequence, it is not going to be a geometric sequence that I can think of. So if you see 0, that is a sign it's going to be an arithmetic sequence or neither geometric nor arithmetic. And we can check, right, also because 6 times 2 is 18. But even if we just had these three numbers, we would know this doesn't work because there's nothing I can multiply 0 by to get to 3. So this is also an arithmetic sequence. We're adding 3 each time. So our next values are 12, 15, and 18. So what would a geometric sequence look like? So a geometric sequence is going to involve multiplication or division. And so for example, we might have one that looks like this. So how can I get from negative 3 to 6? Well, for one thing, I could add 9. Negative 3 plus 9 is positive 6. But 6 plus 9 is 15. So I know I'm not adding. What about multiplying? Negative 3 times 2 is negative 6. So negative 3 times negative 2 is positive 6. And that's my rule here. I'm multiplying each time by negative 2. Negative 3 times negative 2 is positive 6. 6 times negative 2 is negative 12. Negative 12 times negative 2 is positive 24, and so on. So my next number would be negative 48 times negative 2. That would be positive 96. Positive 96 times negative 2 is, I believe, negative 192. And negative 192 times negative 2 is positive 384. So those would be my next three numbers in this sequence. And so similarly for division, we could have a problem like so here again, we might look at this first arithmetically and see, to get from 28 to 14, what can we do in terms of addition or subtraction? We can add negative 14 or subtract 14. Great. What about from 14 to 7? No, that's minus 7, not minus 14. Is there something we can do with multiplication or division? Yes. 28 divided by 4, or 28 times 1/2, which is the same thing, gives us 14. Sorry, I think I just said 28 divided by 4. 28 divided by 2, 28 divided by 2, or 28 times 1/2, which is the same thing, gives us 14. And then 14 divided by 2, or 14 times 1/2, gives us 7. And so our next one would be 7 times 1/2, which would give us 7/2, or 3 5/10. Here it's easier to work with fractions, because to multiply, I'm just going to multiply now by 1/2. 7/2 times 1/2 is going to give me 7/4. 7/4 times 1/2 is going to give me 7/8. 7/8 times 1/2 would give me 7/16. And so if I were typing this into Canvas, I could type this as the next three. I would type 7/2, comma, 7/4, comma, 7/8, comma, 7/16. I would want to put any of these in simplest form if I could, but I can't. And then a good question is, well, could I enter these as a decimal? Yes, you could for these, because these are all terminating decimals. In other words, they all come to an end. They don't go on forever. So that is the exact values. So you could enter 3.5, comma, then half of 3.5. Whoops. Sorry, I want to double check here. Half of 3.5 is 1.75. Then I know 7/8. 7/8 is just one of those fractions you often know, and 7/8 is 0.875. And I don't know 7/16. But checking it on the calculator gives me 0.4375. So either of these would be the next four numbers in the sequence. But again, working with fractions is probably simpler than working with decimals here for our purposes. I don't believe in the homework set that you have to worry with fractions for this problem. For the problems rather that I've assigned in the homework, that's a little hint that your answers will probably be whole numbers, or at least integers. You don't have to worry about fractions or decimals. If you're getting fractions or decimals, you probably want to take a look at it again for this Chapter 1 homework assignment that sequences and series are part of. So I hope this helps a little bit. Sequences and series are a way to start really thinking logically about math, and math is all about logic. So I hope you found this useful. I encourage you to take a look at some of the problems that weren't assigned, especially in Assessment A, which are answered in the back of the book, to get more practice. And if you have any other questions, please let me know. Good luck as you move forward.